Hello friends, this is Priyanka. Today we are going to solve a problem on orthographic projection by the first angle projection method. For important rules, please watch this video till end. So if we observe the given three-dimensional object, we have to first decide what is the left hand side and what is the right hand side of this object. So if we observe, the left hand side is having length 60 millimeter, and what is the length of this right hand side? So if we observe, there is the semicircular arc having diameter 30. So we can say the length of this right hand side is 30 millimeter. So in the first angle projection method, the front view is considered as the principal view. So we have to always consider the front view, which is the side having maximum length. So in between this 60 millimeter and 30 millimeter, we have to choose the side with 60 millimeter length with front view. So this front view is on the left hand side on the given object. So how to plot in the orthographic projection? So for that we have to first take horizontal line as a x-axis and vertical line as a y-axis. And when we plot this front view, top view and side view, there should be some distance in between these views. So for that we have to take some particular distance on both sides of this x and y axis. So suppose we take here 1 centimeter or 2 centimeter distance. So mark here one point 2 centimeter distance above and below of x axis and draw the horizontal line parallel to x axis. In the same way, on both sides of this y axis, we have to mark here the point on 2 centimeter distance and draw here vertical lines parallel to the y axis. So there should be some space in between front view, top view and side view. Now what is the right hand side and left hand side for this orthographic projection? So if we observe, there are 4 quadrants because of x and y axis. So this is the first quadrant, second quadrant, third quadrant and fourth quadrant. So because of this y axis, there are 2 parts, and this part, half portion, is considered as the right hand side and this half portion is considered as the left hand side. So remember that this first and fourth quadrant are on the right hand side and the second and third quadrant are on the left hand side. So how to plot this front view? So if we observe this given object from the front side or from the left hand side, then what length we can clearly or total length we can observe. So we can observe what is the total length and what is the total height. So we have to plot this length and height for the front view. So we will take the right hand side. So this is the right hand side. So we will consider this first quadrant for the right hand side. So what is the total length? So total length is 60 millimeter. So if we observe, these dimensions are so less, so we will use here the scale. So we will use here the scale, that is 1:3. So I will write here. So consider the scale, or I will use here the scale 1:3. So you can use the scale 1:2. That means 1 millimeter in the given problem we will consider here as 2 millimeter for that length. So for this 60 millimeter length, we will take here the total length 180 millimeter. So from this, on this line, we will take here the 180 millimeter distance and mark here one point. And what is the height? So height is given, that is 30 millimeter. So for this 30 millimeter, we will consider here as a height 90 millimeter. So from these 2 points, we will draw here vertical and horizontal line, and at this point of intersection will give us the outline for the front view. Now in the first angle projection method, top view is getting vertically aligned with the front view. So if we draw the projections in vertically downward direction from front view to the top view, so here is the projection. Then this length is getting aligned. So we will get the same length as the length in the front view. Then if we observe this object from the top, then what we can clearly observe? We can clearly observe what is the total length and what is the total width. We cannot observe the height from the top. So we have to plot here. So this is the length that is getting aligned with this front view. So I will write here, this will be our front view, and then here will be our top view. So we have to plot here the width. So what is the width? So width is 30 millimeter. So we have to take here distance, that is 30 into 3, 90 millimeter, and we have to complete this block. So this block will be the outline of the top view. Now we will move for the side view. So this side view is getting horizontally aligned with the front view. So if we take the horizontal projection, so here will be the side view. Now what about the outline? So we can take the projection from top view to the side view directly. So how to take? So for that, in this quadrant we have to take one line that will split this quadrant into two equal parts. That is, this line will split 45-degree angle for this quadrant. Now we have to take the horizontal projection from the top view up to this inclined line, and at the point of intersection we have to take the vertical projection. So here the vertical projection from the top view and horizontal projection from the side view, front view, will intersect at this point. So this point of intersection will give us the outline for the side view. Now we will move for the front view. So in the first angle projection method, front view is considered as the principal view. So we have to complete the front view first. So for the front view, what we can clearly observe? We can clearly observe there is the construction from the base with 9 millimeter height. So from this side there is the construction of 9 millimeter height. So we have to take here the construction, that is the height equal to 9 millimeter, that is 9 into 3, that is 18 millimeter, and we will have to mark here one point. Now again on the other side, what is the height of construction? So on the other side, height of construction is 30 millimeter. So we have to take here the complete height, and here is this height. So now we will complete the outline. Now if we observe what is the remaining length for this construction for 30 millimeter height. So now we will consider what is, or we will decide what is the length for this 30 millimeter height construction. So what is the length? So if we observe, there is 18 millimeter distance is given, but that is passing through the center of that semicircle. So we have to add the radius of that semicircle. So what is the radius of that semicircle? So r is equal to 15, and what is the remaining distance? So it is 18. So we have to take here plus 18. That means here 33 millimeter length is there for this construction, or construction for the height of 30 millimeter. So now here is 33 millimeter. So in this orthographic projection we will take here 33 into 3, that is 99. So I will mark here one point and I will complete the construction. So this is the construction. So how to select the corner point? So for that, now I will take here the line passing through this point. So this is the projection line. So I have used here the red marker. So for the projection lines we have to use the faint, that is projection line should be faint. So we have to use the 2H lead pencil, and construction line should be dark. So we have to use the H lead pencil, and from this point we will use here the projection in the horizontal direction. So here is the corner. So now we will, at up to this point of intersection there is the construction. So we have to show with the help of the dark marker. So this is the construction which we can clearly observe from the front. Now again if we observe, there is the slope. So for the slope, what is the start point? So the corner of this construction of 30 millimeter height and the corner of this 9 millimeter height. So these two corners are the start and end point. So we have to join these two corners. Now this front view is getting completed. Now we will move for the top view. So before moving to the top view, we have to first complete the projections in the vertically downward direction from front view to the top view. So how to complete it? So here are the corner points for the construction. So for this construction corner point, we have to take the projection. So we will take the projection from this point in the vertically downward direction. In the same way, we have to take the horizontal projections also from the front view to the side view. So in this horizontal direction, we have to take the projection. So here is the corner point. We have to take the projection from this front view to the side view. Now if we observe this object from the top, what we can clearly observe? So we can clearly observe there is the semicircular structure at this full width, and then at the same center there is the structure for the hole. So for this semicircular structure 530, that means diameter is 30 millimeter is given. That means radius 15 millimeter. So we have to take here with the scale, that is 15 into 3, that means 45 millimeter distance in the compass, and we have to complete that semicircle. So before that, how to take the center for that semicircle? So it is important. So now we have decided R is equal to 15 millimeter. Now for this 15 millimeter, with the scale we will take here as a 45 millimeter, because our scale is 1:3. Suppose you have taken the scale 1:2, then you can consider here as a 30 millimeter. So for this 45 millimeter, now on this horizontal line we have to select one point for the 45 millimeter, and on this vertical line we have to select here one point of 45 millimeter distance. Now from these 2 points we have to draw the vertical line and horizontal line. Now these two lines are passing through the center, so we have to draw this line in the form of dash and dot. So now I will draw here the vertical line passing through the selected point. So in the form of dash and dot we have to complete this. Now here also we have to draw the horizontal line in the form of dash and dot. So the point of intersection will be the center of the semicircle. Now if we observe this semicircular arc and the hole is having the same center. So what is the radius of hole? So R is 7.5. So if we take R is equal to 7.5 millimeter distance in the compass, and then we have to take, by taking the same center, we have to complete this hole also. So I will complete here the circular arc, and by taking the same center with the help of compass we have to complete this hole also. Now this semicircle and this whole structure is getting completed. Now we will move for the next. So if we observe this object from the top, we can clearly see what is the rib of that slope. So this rib of that slope, we will first decide what is the start and end point. So the start point is here, and here is the projection. So this point is the start point and this point is the end point. So if we project this point, these 2 points are the start and end points along the length. So what is the, where is this slope or the rib of the slope along the width? So if we observe, this rib is from the passing through the middle point. So if we observe here from the middle point of this width, there is the center line which is passing through. So now I will extend this center line in the form of dash and dot. Now what is the width of that rib? So it is given as 7 millimeter. So this 7 millimeter means what? 3.5 millimeter distance from both sides of the center line. So now we have to select here point for the 3.5 millimeter on both the sides. That is half distance on upper side and half distance in the downward side or downside. So now we will select. So 3.5. Now our scale is 1:3. So 3.5 into 3. So it is equal to 10.5. So we have to select here 2 points of 10.5 millimeter. So I will select here 2 points of 10.5 millimeter. So what is the start point and end point? So here is the point. So we have to extend this. So we have to extend this construction up to the start point. So this is the construction for the rib. So this is getting completed. So up to this point, now from this rib point to up to this upper point, the construction is getting completed. So we have to complete the construction. So the construction line should be dark. So with the help of the dark pencil, we have to complete this construction. If we observe this given object from the top, then on the other side there is the inclined line structure. So what is the length of that inclined line? So from the corner, the length is given 9 millimeters. So 9 into 3, that is 27 millimeter. We have to select here one point on the two sides, that is here at the top and bottom side. This is the point. Then what is the width of this inclined line given? So on the width side, the distance is also given, that is 9 millimeter. So again we will select here 9 into 3, that is 27 millimeter on the both sides. So these are the corner points. Now we have to join these corners. So this is the part of construction. So we have to draw the dark line or the construction line. Now remaining we have to join with the help of the dark pencil. So here this construction is getting completed. So this top view is getting completed. Now we will move to the side view. So before that we have to take the projection from this top view to the side view. So we have to take the projection for the all the construction, that is the end points of this hole. Then there is the rib of this slope. So take the projection from these corners and up to this inclined line, and then take the vertical line projection. Now if we observe the structure from the side view, then we can clearly see the base construction having the 9 millimeter height. So here is the projection of the line having 9 millimeter height. So we will complete it. So with the help of this construction line we have to complete this. Then we can clearly see what is the width of that rib. So here the width of that rib is getting projected from the top view, and the start point and end points of that slope are here, that is getting projected from this front view. So here is the start point and here is the end point, and along this height what is the width? So if we observe here, this is the width. So we will select here the point of intersection. Here is also the line of projection. So here is the point of intersection. Now we will join this point of intersection. So this is the rib that we can clearly observe. Then there is the semicircle structure or construction is there, but we cannot observe it. So we can observe it in the form of edge. So we have to just complete this in the form of edge. Now there is the hole. So this hole which we can observe from this top view only, but we cannot observe from the side view and we cannot observe from this front view. So how to show it? So this hole exists all along its height. So this hole is having height 30 millimeter. So we have to show it. So how to show it? So here is the projection of the hole. So it exists on the all along the height. So we have to show it in the form of dash. So for this whole height we have to draw it in the form of dash. So this is getting completed. Now how to show it in the front view? So from the front view we also cannot observe this. So for that we will project this. So for that we have to project the center. So this here is the center of that hole. So this is the projection. Now we will project the end points of this hole. So here we have to take the line. Now this hole exists all along its height. So we have to show it in the form of dash. So here is the projection of this hole. Now we have to show the dimensions. So here are the dimensions. This is the height, this is the length. Then here for this inclined construction the height and length is given. Then here for the hole phi 7.5 we have to show, and for this circular arc we have to show r 15. And here also for the base construction height 12, and here the width of this rib, that is 7. So we have to show the all dimensions, and this is the orthographic projection for the given object.